let us do question number 2, part C. We are told to locate the stationary points of the function given there and determine the maximum and the minimum values of this function. Now, to do this, we are required first of all to get the turning points of this function, and the turning points on a curve are of 3 types. We have the minimum, we have the maximum, and we have the inflection point. In our case, we are needed to find the minimum and the maximum on this particular function. So, to do this, we need to get, or rather we need to understand that the gradient of a curve at a minimum or a maximum, all at the inflection, is equal to 0. That is dy over dx of any function is equal to 0 at a turning point. So in this problem, therefore, we are supposed first of all to get the first derivative of this function, then we equate it to 0, and the equation that we get, we solve for x so that we can get that point that it is that point which is a maximum or a minimum. So let us get the derivative of this function. The function is x cubed minus 12x squared plus 36 x minus 6. So the first derivative of this function is equal to 3x squared minus 24x plus 36. We are going to equate this first derivative to 0 because at turning points the derivative is equal to 0. Therefore 3x squared minus 24x plus 36 is equal to 0 at turning points. Let us solve this equation so that we can get the value of x, so that we can identify the turning points on this curve. So let us divide this equation by 3. So we have x squared minus 8x plus 12 is equal to 0. So that is the equation that we want to solve, and we get now the value of x so that we can get the turning points on this curve. We are going to use quadratic formula. We know that in a quadratic formula, the value of the x is equal to negative b plus or minus b squared minus 4ac over 2a, where the equation is looking like this, that a x squared plus b x plus c is equal to 0. If we want to solve that equation in general, that's the formula we use. We call it a quadratic formula. Let us go back again to our equation. Let us solve it. Therefore, it is going to be negative 8 there, plus or minus square root of b. Our b is negative 8, so this is negative 8 squared minus 4. 4 multiplied by a is 1, multiplied by c, our c is 12. Divide that one by 2, multiplied by a. If we solve this one, we are going to get 8 plus or minus square root of 16, because this is 64 minus 48, you get 16. You divide by 2. Therefore, x is equal to 8 plus 4 over 2, or x is equal to 8 minus 4 over 2. X is equal to 6 or 2 turning points are. One is at x is equal to 2, and the other turning point is at where x is equal to 6. So we have turning points at x is equal to 2, and we have another turning point at x is equal to 6. But we don't know what kind of turning points are these. We don't know whether we have a maximum or we have minimum or even a point of inflection. Now, to do this, we need to find the second derivative. First derivative is equal to 3x squared minus 24x plus 36. That is our first derivative. And to get the second derivative, we are required to differentiate the first derivative to get the second derivative. Therefore, the second derivative here is equal to 6x minus 24. So that's the second derivative. To get whether these points are minimum, maximum, or inflection, we need to substitute each point in this second derivative, and we find what we get now. 6. One of the point is 2, so 6 times 2 minus 24. That is 12 minus 24. We get negative 12. Then this is at x is equal to 2. At x is equal to 2, we find that the second derivative is negative 12. Let us find the second derivative at x is equal to 6. So the second derivative here is equal to 6 multiplied by 6 minus 24, and this gives us 36 minus 24, and that gives us 12. So at x is equal to 6, the second derivative is 12. That is at x is equal to 6. The other one is at x is equal to 2. If the second derivative is greater than 0, the point is a minimum. If the second derivative is less than 0, the point is a maximum. If the second derivative is equal to 0, the point is an inflection. At x is equal to 2, we find that the second derivative is equal to negative 12, and at x is equal to 6, the second derivative is equal to 12. We have now found that at x is equal to 2, the value of the second derivative is equal to negative 12. That means that the point on this curve is a maximum. On the other hand, we have also found that at x is equal to 6, the value of the second derivative is equal to 12. This means that the point on this curve is a minimum. Let us now find the value of this function at x is equal to 2 and also x is equal to 6. So generally the function looks like this. So at here where x is equal to 2, we have a maximum, and where x is equal to 6, we have a minimum. So that's how this function is looking like. So what we are required now to do is to get the value of this here, the value of f of x. at that point, the value of the f of x at that point. We know that the f of x is equal to x cubed minus 12x squared plus 36x minus 6. So to get f of x at x is equal to 2, we have f of x now being equal to 2 cubed minus 12 minus 12, here we substitute the 2 raised to power 2 plus 36 multiplied by 2, this is 2 minus 6, and therefore f of x is equal to f of x at this point is equal to 26. This is a value of our function at x is equal to 2. The value of our function at x is equal to 6 is equal to 6 cubed minus 12, 6 squared plus 36 multiplied by 6 minus 6. So this becomes, that is the f of x now becomes 216 minus 36 times 12, that is 432 plus 36 times 6, that is 216 minus 6, and therefore f of x at x is equal to 6 is equal to negative 6. And that's the value of our f of x at x is equal to 6. And remember, at x is equal to 6, that is where we have our function as minimum. And here we have our function as maximum. Want to connect it to a graph that we can draw the graph and confirm our answers. Let us now plot the function on a graph paper. We see the impression we get. Let us look at the way point A is tracing our function. At point D, the function has its maximum there, and as we approach there, you find that the value of the f of x is reaching its maximum, and its maximum is let us now wait for it to reach its max. Yeah, its maximum is 26, and when point A goes beyond point D, f of x starts to go down. Like now, its value is around 25.9 to 23, and again, as point A is approaching point M, the f of x is decreasing. Like now, it is around -1. It decreases to a point whereby when it goes beyond point M, it is no longer decreasing. At point M, the f of x is exactly -6. Observe the point now. When it is going beyond there, you find that the f of x now is starting to rise again. It is now -5, then -4, again -3, and so on. So beyond now point M, the f of x will keep increasing up to maybe infinity. So these 2 points, point D and point M, we refer to them as the turning points of this function. And at the turning points, the f of x reaches it's either the maximum, the minimum, or inflection point. At the turning points, the dy over dx, or the derivative of a function, is equal to 0. If you look at the gradient of the curve at point D is 0, and also at point M is 0. Therefore, the first derivative of a function at its turning point is equal to 0. And I have said that a turning point may be a maximum, a minimum, or an inflection point. So on this particular function, we don't have an inflection point, but on an inflection point, the derivative is 0, but the gradient of the curve does not change the direction. Like, for example, if you look at this function, before point D, the gradient of the curve is positive. After point D, the gradient of the curve is negative. When now we go to point M, the gradient of the curve before point M, it is negative. After point M, it is positive. On an inflection point, the gradient is 0, but before the point of inflection, the gradient may be negative, then it changes to 0 at inflection point, then after the inflection point again, it stays as negative. Or alternatively, before the point of inflection, the gradient may be positive. At inflection point, it is 0. After the inflection point, it remains positive. So this is our curve, and we can see that it has turning points, that is a minimum at point M and a maximum at point D.